My name is Nikita. I'm a PHP core developer, so I'm one of the people who is working on the PHP implementation. So usually I give talks about PHP internals and how we optimize it and stuff like that. So this time I'm trying something different. Basically, this talk is my excuse to talk about random things in PHP that I kind of find interesting. Because, you know, PHP has lots of quirks, lots of weird language behavior. I mean, it's kind of famous for that. And usually there is some kind of reason why things work the way they do. It's not always a good reason, but usually there is some kind of reason. And I just want to go through a couple of things and explain why they work in a certain way and how that's connected to internals. In the end, I will mostly talk about object properties and maybe a bit of other stuff at the very end, depends on timing. So the first thing I want to discuss is name mangling. So I think this is the most famous like PHP quirks around properties. So if we have this kind of example, so just a class defines three properties. One is public, one is protected, and one is private. And now we cast this class into an array. What do we get? So basically we get what we expect. So we have the property names as the keys and the property values as the values. But we also get some kind of additional stuff. For example, the protected property has this kind of star before the name, and the private property has the class name before it. And if we actually try to access one of those, it's not going to work. So we just get an undefined index notice. Reason is that there are actually null bytes in those keys, and usually those null bytes don't show up if you just show them in the browser or something. But if you actually include them, then you can access those keys. So the question now is, okay, this is how it works, but why does it work that way? It seems pretty random. And the reason is basically that in PHP, inside a single class, you can have multiple properties with the same name. So here we have three classes that extend from each other, so A, B, and C. And each one of those declares the same property. First as private, then as protected, and then as public. And now we try to print out the values. So what we see is that B and C give the same value. So B and C actually refer to the same property. If you have a protected property and then in the inheriting class a public property, then that does not create a new property, it simply changes the visibility level. On the other hand, the private property is actually completely separate. So you have now, in the end, on the class C, you have this private property from A, which you can still access, and the public property from C, which you can also access, depending on where you are in the code. So if you now do the array cast here, if we didn't do the name mangling, we would end up with 2 times the same key, which would be kind of bad. So instead, we do this mangling, so the private property actually gets a unique name that is distinct from the public property. That's the idea here. Yeah. The thing is, this is why it works this way internally. So we want to have a unique name for each property. But there is really no reason why this kind of behavior should also be visible from normal user PHP code. For example, if you use a for each loop, you just loop over the properties in an object, then you don't get this kind of behavior. Because for each will simply give you the properties visible from the current scope. And there is always only one property that's currently visible. So we could do the same here. But at some point, someone implemented it this way. And then some libraries like, I think, Doctrine started using this as a feature because it gives you a fast way to access private properties. This is, I mean, doing this kind of array cast is a lot faster than creating a reflection object and getting the property from there and overriding the private modifier. So instead, they do this kind of cast and get the value. And yeah, because they do it and their code relies on it, we can no longer change it. And that's like usually the case when you encounter weird things in PHP. That's always the reason. Backwards compatibility. It's both a feature and hindrance. Okay, so that was the name mangling. Now the next point is kind of related because it's also about array cast, so array to object and object to array cast. So you know that in PHP it doesn't really make a difference if you use an integer key or if you use a string key that contains an integer. Both of those will refer to the exact same element. The same is also true for objects. So you can have an object property that has an integer value, but it does not matter whether you write it as a simple integer or a string that contains an integer. It's all the same. And the way this is implemented is through normalization. So there are basically two things we can do. Either we say, anytime we see a string that contains an integer, we normalize it to an integer. Or we do it the other way around, and every time we see an integer, we normalize it to a string. So it's basically always consistent in the end. The thing is that PHP does both. So for arrays, it normalizes the keys to integers, and for objects, it normalizes them to strings. And this is not really, you know, just a weird design choice by PHP. There is a reason behind it, because for arrays, integer keys are extremely common. I think it's probably the most common key type. And using strings generally is a lot less efficient than using integers. So that's why arrays normalize to integer. On the other hand, I don't know, I have not actually ever used an integer key on an object. So this is an extremely rare edge case. So PHP does not want to handle it, so it uses strings instead. So we only have to handle a single type. Of course, this is nice in theory, but if you try to mix them, then you have an issue, because they both handle it differently. So if we, for example, create an array with an integer key, and we cast it to an object, then we get a property that you cannot access. So no matter how you write it, there is no way to access this property, and you cannot write to it, you cannot even remove it. It just hangs around there, and you cannot do anything with it. And if you look at the var dump output, you see the reason we have the key 1 to 3, but it's an integer key, not a string key. And objects just don't support that. I mean, it's not the correct normalization. And the same also goes the other way around. So we create an object with an integer key, cast it to an array, and again, we cannot access this element. It just hangs around there, and the only way you can actually see it is in the var dump output. Again, now it's a string with content with an integer in it, and again, PHP just doesn't expect that and doesn't handle the case. Fortunately, this is one of the few cases where it does not look like any library depends on this behavior. I'm not sure how they actually could depend on it, but yeah. So this has been fixed in PHP 7.2. Anytime we do an array to object cast or an object to array cast, we renormalize the keys so they correctly match up. Of course, that also means that those casts have become slower now, but in the end, correctness is usually more important than performance. That's why this was fixed. So new output looks like this, basically everything working as expected, all the keys can be accessed and so on. Yeah. So I don't know, doesn't really fit into the talk, but I'm kind of a performance person. That's mostly what I do, so I can't really resist talking about performance and memory usage. And there are also a couple of really weird effects you get around performance in PHP. So there are like subtle changes you make in the code, and suddenly your memory usage really blows up. I'll show some examples of that as well. But first, just basic comparison. So what uses more memory, an array or an object? And in particular, the case I'm looking at here is an object that has declared properties. So you already know all the keys in advance. You create a class with the necessary properties. So basically, typical value object. And if we now compare memory usage between objects and arrays, those are shown here. So we have how much memory does an array or an object use, depending on how many keys or how many properties it has. So the top two lines are for the array, and the bottom two lines are for the object. And you can see basically arrays use a lot more memory. And there are two lines each time. The top line is the actual memory usage, how it's in reality. And the lower line is the theoretical usage you would get if you just calculate all the sizes and add them together. The reason why there is a difference here is that on a low level, you just can't request an arbitrary amount of memory. So the allocator that PHP uses or that the operating system uses only supports certain sizes. And if you don't match that kind of size exactly, it will round up. And that just shows how much memory we have to round up. So this graph shows exactly the same thing, just as a ratio. So how much more memory does an array use than an object? And you can see that if you have an array with only a single element, then it will use something like 6 or 7 times more memory than an object. So that's the extreme case. And then it somehow tapers off a bit and does a jump. I'll talk about the jump in a moment. But basically, the takeaway is that even in the best case, an array is going to use 2 times more memory than an object. Often it will use something like 3 times or 4 times more. So generally, if you can, always use an object. I mean, not just for this reason, it's also better in general, but this is one more reason why an object is usually a better choice. Yeah, so I posted these graphs on Twitter some time ago, and there was one person asking, well, if objects are so much more efficient, why don't you just implement arrays on top of objects? Which is, okay, fair enough. The reason is just that arrays and objects are optimized for completely different use cases. So objects are great if you have a set of fixed keys, while arrays are good if you don't know the keys in advance, or if you don't even know how many keys you're going to have. And that's why they have this kind of different memory usage and performance characteristics. So for the object, the internal layout in a very abstract level looks basically like this. So an object has some kind of metadata, which I have not shown. It stores which class it belongs to, and it has slots for the property values. And the class is the one that contains a map from property names to the correct slot. So it just says property foo goes into slot 0, property bar goes into slot 1, and foo bar goes into slot 2, and so on. Which basically means we only have to store the property names once. We don't have to store them in every object. Of course, this only works if the properties are actually declared in the class. If you use dynamic properties, then this no longer works. And for that case, we have a separate mechanism. Basically, every object has a properties array, and that's really just an array that maps property names to values. But usually, if you declare properties, this is not used. This is only used if you have dynamic properties. Okay, that's the object. And that's why the objects are efficient. For arrays, we don't have this kind of advantage. We don't know the keys in advance, so we have to store the keys. And we also have to store some additional stuff that makes the array implementation work, so that's the hashes. And additionally, arrays can't have an arbitrary size. So PHP says minimum array size is 8, and then it goes further in power of 2, so 8, 16, 32. So if you have an array with 1 element, you actually have an array with 8 elements. The first one is used, and you have 7 dummy elements. And we do this because array insertions should be efficient, and changing the array size is very expensive, so we can't just change the size every time we insert an element. Instead, we use this kind of power of 2 allocation, so we only have to change the size when we reach a certain number of elements, and in between that, we can directly insert into it. So that's the baseline behavior. Now come the edge cases. So what we have here is, again, a nice class with a single property. We create an object, and this object is 65 bytes large, which is not much. Now, if you loop over this object using a for each loop, so you loop over all the properties on the object, then the size of the object itself changes. Then the size of the object becomes something like 432 bytes, which is 6-7 times larger, or something like that. So doing a for each loop over the object increases its size. And the reason is that this properties array I mentioned, which is usually used for dynamic properties, is also created if you loop over the object. And once it has been created, it will never go away. So until the object is actually destroyed or something, this array will stay on it. And this can actually be a real problem for some types of code. If all the objects suddenly become 7 times larger if you loop over them. For example, in the PHP parser library, where we have huge object graphs which have to be iterated, we use this kind of hack. So actually, on every single class, we have a method that returns the names of the public properties. And then we just do a loop over the names and do a dynamic property lookup using the names. So this kind of dynamic lookup is slow, but it saves us from this kind of huge memory usage increase. Oops. Yeah. So next point is magic getters and setters. So I think it's pretty well known that magic methods in general in PHP are pretty slow. So if we just compare direct property access with a getter method, so an explicit get property method that accesses a private property or something, and we compare that with a magic property access, we see that the method is something like 2 times slower, while the magic method is 6 times slower, or even more than that. So that may seem kind of weird, because I mean, method call and a magic method call are basically the same. Actually, a magic method call is something more specific, so one could think that it will be faster, but it's not the case. And there are a couple of reasons for that. So the first one, and the main one, is that here we have this kind of sequence where we are running user code, so normal PHP code. Then we do a property access, and that's internal code. And then the internal code has to call the magic method. And that's, again, user code. So we have a sequence, user code, internal code, user code. And doing that kind of sequence is slow. And the reason why it's slow is that the way PHP works is basically just a huge infinite loop. So there is a virtual machine which just continues looping and looping, and which has an additional stack to manage state. But usually you only have this one single loop. And then if you have internal code, the loop stops and goes into the internal code. Usually it would just go back and continue looping. But in this particular case, you actually have the virtual machine loop, then the internal code, and then you have to start a new virtual machine loop to run the user code again. So then you have 2 virtual machines being active at the same time, and they have to do state synchronization and stuff like that, and that's really slow. So that's basically the reason. The second problem are the recursion semantics. So usually in PHP, there is no recursion protection. So if you recurse, you will at some point just generate a memory error. If you see a recursion warning in PHP, that means you're using Xdebug. That's not a native feature. The only place where PHP actually checks for recursion are magic getters. So this code will not cause recursion. So you might think it causes recursion because we just access the same property again. So it could like call get property and then again get. But it doesn't. So we protect against that. And the way we do that is using something called recursion guards. And these guards are specific to the property name and to the type of the access. For example, if we are currently accessing the property foo, so we are in the getter for foo, then accessing the property foo again will not call the getter. Instead, we just access the property directly and get probably an undefined property error. If we access a different property, bar, we do get recursion. So we call the getter again, because the property name is different. Similarly, if we access a property foo, but we don't read from it, we write to it, we also will call the magic accessor, so we call the setter. We only get the recursion protection if both the property name and the accessor type are the same. And this is implemented using a simple array. So we just have a map from property name to a bit set that contains all the currently active accessors. So in this case, we have get foo, get bar, and set bar. So in the recursion guards, we have foo in a get and bar in get and set. And the actually interesting part here is what happens if we leave the function. So once the set is done, we remove the set bit. And then once the get is done, remove it as well. And then again. So what we have now is, for 2 properties, we're not inside any kind of magic method. but the information is still there. So this array will still stay on the object. It does not get cleaned up. And once again, there is no way to remove it. This kind of, yeah, it's basically effectively a memory leak, will just stay on the object forever. So if you have magic methods and you access lots of different property types, properties through them, you will get a memory leak because of this kind of behind-the-scene recursion management. And yeah, usually there is no way to actually see this. I mean, PHP does not really have any kind of memory debuggers. So if you don't happen to be familiar with it, there is absolutely no way you're going to find this kind of leak. The good thing is that in PHP 7.1, this has been mostly fixed. So if you don't do anything overly weird, if you only access one property at a time, so you don't have this kind of recursion get foo, get bar, then we no longer use this kind of guards array. We only store the current property and which accessor we are in. And in that case, we no longer have this kind of effective leak. So if you're on a sufficiently recent version, that's not a concern anymore. Okay. So this will be the last one about the properties. PHP allows unsetting properties. I mean, that's not a surprise. What is a bit surprising is that you can also unset properties that have been explicitly declared. And this works the same way as usual. So you unset the property, and then next time you get an undefined property notice. The reason why this is kind of interesting is that once the property is unset, it's no longer initialized, so the magic getter will be called the next time it's accessed. Which allows you to perform some kind of lazy initialization. So for example, again, we have a class with a declared property. In the constructor, we unset the property, which means that the next time it's accessed, we will be calling the getter. And here, the getter does some kind of initialization and returns the value. So for the two accessors at the bottom, the first one will call the getter and initialize the property, while the second access will no longer call it because the property is now initialized, so it's accessible, and we access it directly. So in the end, what this basically means is that you get the benefits of a declared property. So, apart from documentation, also the access is fast and it does not use a lot of memory. And you combine that with the possibility of having some kind of lazy initialization. And this kind of functionality is also heavily used by some libraries. For example, I think Doctrine is pretty much based on this, which I actually found out only relatively recently because supporting this internally is a bit of an inconvenience because we have to check for undefined properties all the time, even though we would prefer not to. So we just figured, okay, let's remove this. I mean, why would anyone ever want to unset a property they have explicitly declared? It doesn't make sense. But yeah, then some people pointed out that actually all their code depends on this completely, and we better not drop it. So that's why it's still there. Okay. So there is still some time. So there is only a limited amount of things I can say about object properties. So I have to switch to a different topic now, which is scoped calls. So here we have a something that looks like a static method call. So usually if you see class name, double colon, method name, that's a static method call. The thing is, the double colon in PHP is not called static access operator, it's called scope resolution operator. And there is a reason for that name. So I think one case that anyone has encountered is this one. So the way you call parent methods in PHP is you write parent double colon method. And I've seen this question quite a lot, why we use this kind of syntax, because really this looks like a static method call, even though it actually isn't. So this is calling an instance method, not a static method. And the thing is, this is not some kind of magic relating to parent methods. So the parent here is, I mean, you can replace the parent with the class name, it will still work. This is actually a different type of call separate from the static call. So this is what we call a scoped instance call, which just calls a method on a certain class with the current this value. And this also works not just for parent methods, you can, for example, also call a grandparent method using that. So we skip the method B and we call it on A directly. Probably the most interesting case is what happens if you don't have this kind of inheritance hierarchy and you have two completely unrelated classes and you try to do this. So if we have something like this here. Now A and B are completely separate, but we still try to do the same thing. And what happens now depends on the PHP version. So in PHP 5, this actually worked. So the method on A would be called, but the value of this would be the class B, even though it's not related to A at all. So in PHP 5, it was possible that you are inside the method on a certain class, and this value you get is not related to the class at all, which is unexpected. And because of that, this has been deprecated for quite a while already, I think since 5.2 maybe. So in PHP 7, this will no longer work in the same way. So in PHP 7.0, it throws an undefined variable this error. And in PHP 7.1, it throws a hard exception. Okay, then one more example in this context. I think this is actually the case where people encounter this idea of scoped instance calls most commonly. So PHP has call and it has call static. So call is used if you have an undefined instance method, and call static is used if you have an undefined static method. The thing is, you cannot always distinguish whether a call is static call or an instance call. So here at the bottom, this one will always call the call static method because it's clearly static. On the other hand, the call inside the doCall method could mean two things. Either it is a static method call, or it is a scoped instance call. So it actually calls the instance method foobar inside the current scope. And PHP, for some reason, decides that it's actually a scoped instance call. So it will call and not call static, which I think is not what most people expected to do and wanted to do. So lots of bug reports about that one. Okay. I think I'll actually stop at this point. Or one more. This one is simple. So PHP has closures. That's nice. And at least since, I think, 5.3 or 5.4, you can use this inside closures. And there is a little-known feature, which is static closures, which allows you to explicitly say, OK, I don't want to use this. If you specify static before the closure, then this will not be available. So the question is, why do you want to do that? I mean, if you don't want to use it, just don't use it. And there is, I think, exactly one use case for this, and that's to avoid circular references. So if we don't have the static here, then the closure references the this value, and the this value has the closure inside the property. So we have this kind of cycle between the object and the closure. And in PHP, if you don't have cycles, then objects will be destroyed as soon as they're no longer used, so pretty much right away. On the other hand, if you do have cycles, then you have a completely different garbage collection mechanism, which runs at regular intervals. So in that case, the object will be destroyed at a much later point in time. And in some use cases, for example, if you're writing an event loop implementation, doing some kind of asynchronous processing, then this suddenly becomes really important, and that's where you use the static closures to avoid cycles, to avoid delayed destruction. But OK, that's really it. So thanks for the attention.